Hi everyone, it's me, Eric, and today I'm traveling with my ATM to fix the chlorination tank of a community's water reservoir. As explained in my previous videos, chlorination tanks are used to help treat water by killing off bacteria that might have contaminated it. As we head up the mountain, we finally reach the water reservoir. At the moment, there is no viable chlorination system in the community, so we're trying to fix this chlorination tank as soon as possible. We first start off by cleaning the tank itself. All the white powder you see is calcium sediment, a byproduct from calcium hypochlorite mixed in the water. Calcium hypochlorite is a chemical used to create chlorine solution, as it releases chlorine when mixed with water. We want to wipe down the tank so there isn't anything that can obstruct the pipes going through it. From there, we begin replacing the pipes, so the water can flow into the tank and then the reservoir. There's a bit of a time crunch because in a couple of days, we'll have a capacitación, training session, where we'll use this reservoir and chlorination tank to teach different classes in the area how they should treat their water systems with chlorine and how to measure the right amount of calcium hypochlorite needed. This capacitación was a joint training session with a local health post, where they started off by talking about ways to prevent the spread of dengue and ways of preventing insects from contaminating your water. Afterward, it was my turn to explain to the Hasses about chlorination measurements. Now for a small trigger warning. The following section will contain math. Anyone that does not want to learn about the proper way to calculate the needed amount of chlorine to treat rural water systems should skip to this part of the video. Now, with that out of the way, here's a simple model of a water reservoir. You can see water from a spring or other source enters the reservoir, where it is held until being used by a community. As water moves through the reservoir, drops of chlorine solution, better known here as solución madre, enter the reservoir from the tank above. As explained before, solución madre is a mixture of water and chlorine. Normally, granulated calcium hypochlorite is used, but other chlorine products can also be used, depending on the preference of the district. However, for this instance, all calculations will be done with the basis that calcium hypochlorite is used to chlorify the water. To determine how much chlorine to mix into the solution, or more specifically, calculate the necessary weight of calcium hypochlorite being used, we use this equation. P is the weight of the needed calcium hypochlorite in grams. Q is the flow rate of the water entering the reservoir in liters per second. One of the most effective ways to calculate the flow rate is filling a bucket with water entering the reservoir and timing how long it takes to fill. The flow rate would be the volume of the bucket divided by the time it takes to fill. It's recommended to measure multiple times and divide the volume by the average time it takes, so as to get a more accurate estimate of the flow rate. Moving on, T is the time until the tank will be refilled. This number is up to the Haas, or whoever will be in charge of recharging the solución madre. From personal experience, this is normally done every week. Be aware that for this equation, T has to be in seconds. So if you're recharging the tank every week, which is 7 days, that comes out to be 604,800 seconds. C2 is the desired concentration of chlorine in the drinking water. This number will always be 1.5 milligrams per liter, as that is the recommended concentration of chlorine in water that is safe to drink. Q times T times C2 is divided by 10 times the percentage of chlorine, which is the amount of total chlorine in the calcium hypochlorite product being used to treat the water. The calcium hypochlorite product you are using will have a label indicating the percentage of chlorine it contains. For this specific equation, you need to annotate the percentage of chlorine as a whole number. This means that if I'm using a bottle of granulated calcium hypochlorite that has 70% chlorine, I will need to put the percentage of chlorine as 70 into the equation, not 0.7. Once you have plugged in all the values into the equation, you're able to find the needed weight of calcium hypochlorite to make the solución madre. However, as the process of chlorification is toxic, it is necessary to wear personal protective equipment before handling any chemicals. As you can see, I'm wearing goggles, a respirator mask, and a hazmat suit in order to work with the chlorine. I also wore rubber gloves, but I didn't put them on until I started the process of mixing water with the calcium hypochlorite. Now, you shouldn't put all your calcium hypochlorite and water all at once in the chlorination tank, as you want the chlorine solution that is released from the calcium hypochlorite mixing with the water, and avoiding the calcium byproduct from clogging all the tubes. Instead, mix 10 grams of calcium hypochlorite per liter of water in a bucket and stir it until it is mixed. Then, cover the bucket and wait 10 to 30 minutes before pouring the solution into the tank. Avoid dumping the sediment into the tank, as that is calcium. Instead, dispose of it somewhere else. Once all the chlorine is in the tank, you can fill the rest of the chlorination tank with water and begin calculating the drip rate of the solución madre into the reservoir. As such, warning, more math ahead. The drip rate is simply how many milliliters of the solución madre would enter the reservoir every minute, and it's quite simple to calculate. The drip rate is equal to the volume of the solution in the tank, normally how much liquid is in the tank when it's full, divided by 1.44 times T, the time until the tank will be refilled, already previously calculated, only this time T has to be in days and not in seconds. Once you know how many milliliters of chlorine solution should enter the reservoir per minute, you simply need to adjust the chlorination tank's exit valve to reflect that. This means while someone slowly turns the exit valve, someone else is timing how much solution is entering the reservoir per minute until the wanted amount is reached. And that's how you treat water in a reservoir. The capacitación itself was a success, as multiple host members and people of the surrounding communities were able to learn and understand how and why we chlorinate water. I also hope you watching the video was able to learn something new about this process. But for now, that's it for me. So thank you very much for watching, and see you next time. Okay, bye!